You know, Eddie What's-His-Name isn't the only guy to make a Frankenstein guitar. Okay guys, well, the canvas is blank, and what that means is it's time to start a new guitar building project. And as you can tell by the title of this video, this one could get very interesting. In the past, when I've made guitar building videos, if it was a simple guitar project, I could do the entire build in one video. However, in other projects that I've embarked upon, it made more sense to do multiple parts so that I could explain all the detail. And I think that this upcoming build is going to warrant multiple parts. And it could take a month or two to completely finish this project. So bear with me. But what the plan is, like I said, as you can tell from the title of the video, I intend to combine the features that I like from a headless guitar design into a guitar, into more of a traditional guitar, a guitar that has a headstock. Okay, I know that sounds strange, but again, like I said, bear with me. In this episode, I'm going to try to explain the concept and where my thought process is coming from. To begin with, I've noticed over the last few years that headless guitars have increased in popularity. In fact, I posted up a video a while back, and I'll link to it up above, where I talked about headless guitars and their sudden rise, it seems, in popularity. And my theory is there is a younger generation of guitar players who have yet to be infected with the disease of tradition, and therefore are more accepting of the idea and the concept behind the headless guitar. So they're kind of driving some of that increase in popularity. However, I've always had some issues with the headless guitar, and I think part of it is rooted in both tradition and functionality. From a traditional standpoint, I just don't like the way they look. I said it. I'm sorry for those of you out there who are big headless guitar fans, but personally, I just don't appreciate the aesthetic. When I see a guitar that doesn't have a headstock, I think it was either a mistake or it's broken. And when I see guys up on stage playing headless guitars, to me it just looks like a gimmick, and like they're playing it to get the attention. You know, and that's okay, because let's face it, guys who are jumping around on stage with an electric guitar are trying to get attention. So from that perspective, I just have never been able to appreciate the look of a headless guitar. Now that could change. For example, when I first started building guitars, I couldn't stand the look of a Telecaster. I just didn't like the way they looked. But here we are 20 years later, and I love the way Telecasters look. Conversely, at the beginning when I was first building guitars, I really liked Stratocaster guitars. I like the shape, I like the design. Today, however, I've kind of shied away from the Stratocaster because I don't like the round over edges. Every time I see them, I think it looks like a blow-up toy. So I've just kind of veered away from it. So, you know, throughout the course of a person's life, a guitar player's life, I think it's possible to dislike a design and then slowly come around to where you like it, you know, or vice versa. And right now, as it stands with the headless guitars, I'm just not a big fan. And maybe that will change as we continue to see their popularity increase. But for now, I'm just not there. I'm not on board with it yet. But there's another issue. It's the functionality. And the only aspect of the functionality that I don't appreciate is the fact that, and I think many of you who played headless guitars will agree, they are not as easy to bend the strings on. When you play them, the strings just feel a lot stiffer on a headless guitar. And part of the reason for that is because on a traditional guitar with a headstock, The string continues past the nut and then wraps around the tuner. This extra length of string makes it feel a lot easier to bend. And it's a noticeable difference. And for folks who will pick up a headless guitar and play it for the first time, that's one of the first things they notice is how stiff the strings feel when they try to bend them. And that can be really disconcerting. And let's face it, with guitars, if it doesn't feel right, you're not going to probably lay out the money to buy it. You're just going to pass on it and keep searching. So what I decided to do was come up with a design where I could combine the features that I do like from the headless guitars with the features that I like from a traditional guitar. And one of the things I've also done is I've already sourced my bridge solution that I'm going to be using on this guitar. And they are solo bridges. Now, one of the things I like about the headless guitar, and what has always intrigued me about its design, is the fact that you're combining two separate components into one. You're taking the tuning pegs from the headstock and combining them with the bridge. And to me, that just makes a lot of sense. It simplifies the overall design and concept of the guitar. And there's a couple of other issues. Whenever I've built a guitar with a headstock and tuners, one of the issues I have with the traditional design is the fact that you have to reach up here to tune the strings while picking the string down at this end. And if you're a real stickler for intonation, you know that that sometimes can be a problem, because any weight that you put on the headstock as you're tuning it can throw off the intonation ever so slightly. A lot of folks aren't going to notice that, and they could care less, and they'll probably laugh when they hear me say that. But there are many of us out there who the slightest effect against intonation that we experience can drive us crazy. And I know that messing with the tuning pegs as you're trying to tune the strings can affect the intonation. I would much rather pluck the string and tune it without touching the neck at all. So that's one of the features that I like with the headless guitar design. So what I want to do now is jump on the computer, and I'm going to show you the guitar that I'm designing and kind of explain some of my thought process. What I have here is a full-size, full-scale 3D mock-up of the guitar that I'm going to build. And I'm calling this the Delta. If you've been watching my guitar building videos recently, you'll know that I've been naming them based on the letters of the military alphabet. So I have the Echo, the Bravo, and now the Delta. And what I did was I laid out this guitar with all the components, and I did this so that I can check to make sure that everything is going to line up properly and that there are not going to be any issues that I will encounter, especially when I get to the final assembly stage. Because there's nothing more disappointing than to start assembling a guitar only to notice that your strings are too close to the edge of the fretboard, or that you haven't positioned the bridge correctly in order to make the scale length work. So I've got this all laid out, and I've got the bridges rendered here, and these are all, perfectly scaled. And on the neck, which is a 25.5-inch scale length neck, I've actually incorporated the 12th fret as well as the 1st fret. And I did that so that I could lay out this guitar and make sure that I have the spacing dimensions correctly, especially for like string action. Before I continue with this video, I wanted to remind you to like, comment, and share this video as a way to support my channel. If you would like to do more, you can either click the thanks button down below and leave a tip in the amount that you choose, or you can visit my YouTube store, which is displayed below the description for this video. Oh, and don't forget to subscribe to my channel so you won't miss any future guitar building videos. Now, along the way, as I was laying this out, I discovered a bit of an issue, and that was the height of the bridge when it's mounted to the body, right to the top of the body, will place the bottom of the string about a half an inch off the top of the body, even when the saddle is as low as it can go. That's basically the same dimension as what you would find with a tune-o-matic bridge on a guitar like a Les Paul or a Gibson SG. Now, the problem that creates is it raises the strings way too high off of the frets when the neck is installed level with the rest of the body. The way that the Gibson guitars account for that is they angle the neck down towards the headstock, and that pulls the string down closer to the 12th fret. Well, that was one way that I could solve that problem. Another way is to raise the neck out of the body. But the problem with that is it makes the neck too high out of the body. It looks weird, and it affects playability. It makes it feel odd to play. But the other option, and this is what I decided to do, is I could recess the bridges down into the body, thereby placing the strings closer to the 12th fret when the saddles are adjusted as low as they can go. So what I did was I will route these slots into the body where the bridge will mount, and these will accommodate the base plate for each of the individual tunable bridges that I'm going to be installing on this guitar. And then I cut a slot between all 6 of those bridges so that I can lay a piece of copper foil tape in here, which will then be soldered to a wire that runs into the control cavity and will be grounded, thereby grounding all 6 of the bridges and all of the strings. Another issue that I ran into, it really has to do with the fact that since I'm using CAD software to design and lay out this guitar, as well as CNC technology to carve it, I'm able to achieve a very high degree of precision accuracy. And it allows me to quickly and easily lay out the strings in an optimal manner. And by that I mean I could position the strings so that, for example, the low E string, the edge of the low E string, is exactly 1/8 of an inch from the edge of the fretboard, 0.125 inches, or slightly more than 3 millimeters. But I also wanted the high E string to be placed with the same distance between the edge of the string and the edge of the fretboard. And I wanted that to be consistent from the nut all the way to the heel of the fretboard. I also wanted to make sure that the strings are visually spaced correctly. And that means that instead of having a consistent dimension between each string, it's going to change slightly with each string because the strings go from thin on the high E to thick on the low E. So the distance between them isn't the same when measured precisely. However, it is visually correct. Well, once I had all this laid out, what I discovered was the neck is going to be slightly off center from the body. And that may seem like a mistake, but it's not. It's actually correct. And it's going to place the strings over the center of the guitar so that when the pickups are installed, the strings pass directly over the pull pieces. But it does mean that the neck is slightly off center in the body. Also, the neck itself is not symmetrical from one side of the center line to the other. It's slightly different. However, I doubt anybody would ever be able to notice that because when measured, the dimensions that are different are different by like a 64th or even like 128th of an inch. It's fantastically small. so you're not going to see it and you're not going to feel it. However, since I'm using 3D CAD software and CNC technology to build this guitar, why not make it that accurate? Why not try to lay everything out as precisely as possible? Doing so means that I can rest easy as I'm cutting, carving, and assembling this guitar, knowing that I'm not going to run into any issues with something being slightly off. Everything should fit together and work exactly as I expected it to, or as I would like it to. Now, when it comes to the design of this guitar, because I'm combining the traditional design of a 6-string guitar that has a headstock with a headless guitar design, as you can see on the headstock, that's where I'm positioning the retainers that will hold the strings. Now, the way I'm going to make this guitar work is when you string it up, the ball end of the string will enter the string retainer and will be held in place by the design of the string retainer. There's no need to clamp it into position with a set screw. The other end of the string will then feed into the bridge, where it will be held in place with a set screw. It's actually a little thumb screw that can be tightened to hold the string, and then the string can be tuned. And as you can see, the placement of these string retainers allows for a significant amount of extra string from the nut down to the retainer, and that, I'm hoping, is going to make the strings easier to bend. So that's kind of the overall plan for this guitar design. And as you can see on the headstock, I'm incorporating this lion logo, which I've decided to add onto all of my guitars going forward. So I think it makes for a kind of a cool looking headstock shape. We'll see. You know, a lot of times when you go from a 3D rendering to the actual finished piece, you start to see things that you may not have noticed before. But I've done this enough that I'm able to anticipate all the potential issues. Okay, hold the phone. After I had finished editing this video and before I posted it up onto YouTube, I actually got started on constructing this guitar, carving it out on my CNC machine. Well, one of the first things I had to do was to plane the top and the bottom of the body blank before I could actually start doing the CNC work. And the reason I did that was because when I glued the two halves of the blank together, the gluing edge was not at a perfect 90-degree angle to the top or the back. So when I brought the two together, it kind of made the blank a slight V. And normally when I plane a guitar body blank, I'll do that before I join the halves together. I'll plane each side separately because I only have a planer that's 13 inches wide. It can't accommodate the full width of the blanks that I use. And apparently it's when I ran the gluing edges over my joiner blades, apparently the fence was not set at a perfect 90-degree angle to the blades. And as a result, like I said, when I joined the two together, it was at a slight V. So I needed to plane the surface down to get it flat. And I did that using my CNC machine. However, once I had finished planing both the top and the back, I measured the thickness of the blank, and it went from 1.75 inches, which is what I was planning for, to 1.6 inches, which is 0.15 inches thinner than what I was intending. So I knew right away I needed to jump back on and check this out with my full-size, full-scale 3D model to make sure that this was, wasn't going to be too big of an issue. And I knew that I was going to have to probably adjust the depths of the control cavity as well as the routes for the neck bolt ferrules. So after I checked it out on the computer to make sure everything was going to work and made some minor edits, it works out perfectly. And the cool thing is now the body is going to be 1.6 inches thick instead of 1.75 inches thick, which will make it lighter and a little sleeker in design. It's sort of like a thin line Telecaster or something like that. So now I'm good to go. Whew. So hopefully you've enjoyed this video or found it inspiring or educational. And I hope that I've earned a thumbs up from you. And if you'd like to follow along with this guitar build, I'm not sure how many parts it's going to take, but I would encourage you to click the subscribe button down below and click the bell for notifications, and make sure you have notifications turned on so that you'll be notified each time I post up a new guitar building video to my channel, and you can check it out right away and not miss anything. So until the next episode, as always, take care, stay safe, and I'll see you soon.